Dear students, warm wishes of the day. Welcome to the online learning platform of JET. I am Dr. K. Magendran, Department of Electrical and Electronics Engineering, Janssens Institute of Technology. Today, we are going to discuss the topic of energy meter and power consumptions by home utilizations. I hope all are aware of the energy meter used in our home to record the utilization of electrical energy. These are the contents of today's presentation. In this session, we are going to discuss energy meter and its types and power consumption by various equipments and EB bill calculation details. Energy meter, it is also called as electricity meter. Energy meter is a device that measures the amount of electrical energy consumed by a electrical load. What is the amount of electrical energy consumed by a electrical load? What is meant by electrical energy? The electrical energy is the product of power and time of how long the power is consumed. The energy is equal to power into time. The unit of measurement is kilowatt hour. What is kilowatt hour? The amount of energy consumed by 1 kilowatt load over the period of 1 hour. Then electrical load. What is by electrical load? A device which is associated with electrical supply, that is called electrical load. Examples are the various electric bulbs, fans, televisions, iron box, or all electrical and electronic equipments are called electrical load. Different types of energy meter based on the application, based on the power rating, based on the location. There are n number of energy meters are there. Here we are going to discuss about only three. One is induction type energy meter, the electronic energy meter, smart energy meter. The induction type energy meter is based on the electromagnetic induction principle. It is also called as electromechanical device. It is a conventional one. It gives less accuracy. There is accuracy is very less. That is the main disadvantages of this induction type energy meter. Number two, electronic energy meter, that is digital meter. Electronic meters measures the energy using highly integrated components, which gives the high accurate. Compared induction type energy meter, it gives accurate value. The third one is smart energy meter. A smart meter is an electronic device that records consumptions of electrical energy and communicates the information to the electricity supplier for monitoring and billing. Smart meters enable two-way communication between meter and the central system. Basic operation of induction type energy meter. The basic principle of induction type energy meter is electromagnetic induction. The construction wise, the energy meter has four main parts. They are driving system, moving system, braking system, registering system. Number one is driving system. In driving system, the electromagnet is the main component of the driving system. It is the temporary magnet which is excited by the current flow through their coil. The core of the electromagnet is made up of silicon steel lamination. The driving system has two electromagnet. See in the figure. The upper one is called shunt electromagnet and the lower one is called series electromagnet. Next, moving system. The moving system is the aluminum disc is mounted on the shaft of the alloy. The disc is placed in the air gap of the two electromagnets. Then the eddy current is induced in the disc because of the change of the magnetic field. This eddy current is cut by the magnetic flux. The interaction of the flux and the disc induces the deflecting torque. When the device consumes the power, the aluminum disc starts rotating, and after some number of rotations, the disc displays the unit used by the load. The number of rotations of the disc is counted at particular interval of time. The disc measured the power consumption in kilowatt hours. The third one is braking system. The permanent magnet is used for reducing the rotations of aluminum disc. The aluminum disc induces the eddy current because of their rotation. The eddy current cut the magnetic flux of the permanent magnet and hence produces the braking torque. The braking torque opposes the movement of the disc, thus reduces their speed. The permanent magnet is adjustable due to which the braking torque is also adjusted by shifting the magnet to the other radial positions. The fourth one is registration, the counter mechanism. The main function of the registration or countering mechanism is to record the number of rotations of the aluminum disc. Their rotation is directly proportional to the energy consumed by the loads in the kilowatt hour. The rotation of the disc is transmitted to the pointers of the different dial for recording the different readings. The reading in the kilowatt obtained by multiply the number of rotations of the disc with the meter constant. Okay, induction type energy meter. This is the circuit diagram and the practical view, internal view of induction type energy meter, and working of induction type energy meter, which is discussed previous slides. It shows a clear construction of induction type energy meter, internal view and practical view of induction type of energy meter. Electronic energy meter. Electronic meter measures energy using highly integrated components. These are very accurate and reliable type of measuring instrument as compared conventional mechanical meters. It consumes less power and starts measuring instantaneously when connected to load. These meters might be analog or digital. In analog meters, power is converted to proportional frequency or pulse rate. In digital meter, power is directly measured by high-end processor. The power is integrated by logic circuits to get the energy, and also for testing and calibration purpose it is then converted to frequency or pulse rate. Features of electronic energy meter. Here we are using display in LCD and LED monitors. It shows a accurate value and compared conventional meters. Here we easily calculate real, reactive and apparent power. By using these values we can easily calculate power factor and other values. And also we can get various records like billing information, data, monthly data, yearly data and other. For those data we can easily taken from the energy digital energy meters, and we can specifically have to store the data values in meter itself. Also we can generate report based on the any manner. Sometimes it use useful for prepaid future. Power consumption details of various home appliances. In this session, we are going to learn that how to calculate power consumptions of individual loads. Here I have chosen some of the home appliances. The first one is incandescent bulb. The rating of incandescent bulb is 60 watts. The average usage per day is equal to 8 hours. The average usage per month is equal to 30 into 8 to 40 hours. Now we can calculate the power consumed per month is equal to 240 into 60, 14,400 watts. The 14,400 divided by 1000 is equal to 14.4 kilowatt. That is 1 kilowatt is equal to 1 unit. So 14.4 kilowatt is equal to 14.4 units. Next, LED bulb. The rating of LED bulb is 12 watts. The average usage per day is equal to 8 hours, similar to incandescent bulb. The average usage per month is equal to 30 into 8 is equal to 240 hours. The total power consumed per month is equal to 240 into 12 is equal to 2880 watts. That is 2.88 units. Then ceiling fan. The power rating of ceiling fan is 75 watts. The total power consumed per month is equal to 22.5 units. Then mixer grinder. Mixer grinder we are using average usage per day is 0.5 hours. The total power consumed per month is equal to same 22.5 units. Then LED TV. The power rating of LED TV is 55 watts. The total power consumed per month is equal to 55 into 240, 13.2 units consuming this LED TV. Next load is air conditioner. The star rated 1.5 ton power rating is 1425 watts. The average usage per day is 8 hours assumed. The total power consumed per month, if we calculating, means 1425 into 240 is equal to 3,42,000 watts divided by 1000. 342 kilowatt is equal to 342 units. The air conditioner load consumes more power. This is the power consumption detail of various home appliances day-wise and month-wise. Just we take this table as an example of power consumption detail of any middle-class family house. See here, by using this table, you can calculate power consumption details of your home. Yes, take a one white sheet and list the available electrical loads in your home and write the power rating of all loads with the help of their nameplate details. Now you fill that the row-wise details. First you fill the appliance name, then quantity, next the power rating. The fourth one is hours used per day. That is utilization hour. Fill that utilization hour. Then watts hours per day. The formula is quantity into power rating and hours utilized per day. Finally, watts per month is equal to 30 into previous result.
Just follow these simple tips and you'll soon enjoy great savings on your energy bill. Did you know that hot water systems are the biggest energy user in most households, accounting for around 30% of a home's energy use? Whenever possible, use cold water instead of hot. Washing your clothes with cold water is a good place to start. The average shower head uses at least 10 litres of water per minute. That's a lot of water. Install a low-flow shower head to greatly reduce the water flow. Take shorter showers. Use a shower timer and try to keep it under 4 minutes. Refrigerators typically account for 15% of a home's energy use. Make sure yours isn't using any unnecessary energy by setting the temperature correctly. 4 degrees for refrigerators and -15 degrees for freezers will ensure safe storage of food and minimal energy use. Do you own a second fridge? If it's only used for drinks, switch it off when you're not using it, or put a timer on it. If you find you never use it, why not get rid of it? It could be adding hundreds of dollars to your energy bill. Appliances on standby account for around 10% of a home's electricity usage. That can cost you well over $100 a year on wasted energy. The easiest way to save energy is by switching off appliances at the wall after using them. Enable the energy-saving features on your computer and switch it off at the wall after use. And of course, don't forget to switch the lights off every time you leave a room. How well your house keeps out unwanted weather doesn't just affect your comfort, it also greatly affects your energy use and bill. Heating and cooling typically accounts for around 25% of a household's energy usage. Check the seals on your windows and door joins to make sure hot or cold air isn't escaping. If it looks like there are gaps, visit your hardware store and ask about materials to improve seals. Only use heaters and air conditioners when you need to, and close doors to stop energy from going to waste. Air conditioning isn't the only way to keep your house cool. Use fans, cross-ventilation and external shading whenever possible. Or for a cheaper, more natural solution, planting deciduous trees on the western side of your house can provide shade in summer while letting light through in winter. Thanks for watching. If you want to know more, grab a